So is it having any thing that one? It's having velocity. So it is also having delta x. The moment I open up hole, this layer of liquid will emerge from the container. It will have density rho. It will emerge with a speed, no? And it's having a mass delta m. So shall I say that as good as this liquid is throwing certain object, go for conservation of linear momentum. If a person standing on a trolley, if he makes a jump, then what will happen to the trolley? Trolley will recoil back. The same thing should happen for this particular container. It is throwing out certain mass with a speed v. What is the mass? Delta m. So it should recoil, no? It should experience a force. So now how to calculate that force experienced by that? So I'll take help of this one. F thrust equal to U relative or V relative dm by dt. We'll agree this. With what speed it is projected? Container at rest. So then what is the velocity of ejected fluid? What is velocity of ejected fluid? Should be V. So this V relative is in fact is V because container at rest V. Then dm by dt. What is dm? Mass of that small element. That should be equal to right like this. So delta m rho area of cross section of hole. What is small a? Okay, dA, and this is delta x. V rho a will come outside. Delta x by delta t. So this should be again velocity of flex only. So what is F thrust now? Rho a b square. What is a? Area of cross section of hole. There's a hole. So in what direction the thrust force will act? Like this. So the whole container will experience a thrust force, and in what direction that will act? That will act towards left. So if you leave this container like this, so what will happen to this emerging liquid? The jet will exert a force and the container starts moving backward. And the thrust force depends on what? At what depth the hole is located. You see this one. Because the V depends on what? V depends on H. No? Again, what is V? Velocity of flex, root of 2gh. Fine. There's a condition. So the thrust force will act here. Now, if it is kept on rough surface, there'll be friction. Friction will act as there'll be friction will be acting. So like that, we'll get plenty of numericals now application oriented. So what is this? What we should call force, thrust force, exerted by jet on container. The emerging liquid will exert force, or shall I say change in momentum? Say what was the before opening hole, what was this layer? This layer was at rest. The moment you open hole, the liquid will emerge with a speed. The liquid will emerge with a speed. The emerging liquid what will acquire momentum. It was at rest, then it acquired momentum. So definitely there should be force. So Newton's laws of motion, action, reaction, equivalent, opposite. So therefore now the emerging liquid will exert a force on the container and that will act backward, opposite to velocity. Why thrust force should be opposite? Go back to the variable mass concept. Here, what will happen to total amount of liquid? Decreasing, no? If a mass of system decreases, in what direction the thrust force will act? The thrust force will act opposite to U relative variable mass concept. If the mass of system increases, so dm by dt, what it should be? It should be positive. But here mass dm by dt is negative. So in fact, I should bring negative sign. You'll get confused. Just I wanted only magnitude. So you have to ask questions, sir, why this is backward? Because the mass of the liquid in the container decreases with the time. So therefore, the thrust force should act opposite to U relative. Sir, why you are writing U relative equal to V? Container attached. The moment you open hole, the liquid will emerge, no? So therefore, what is the velocity of the emerging liquid with respect to container? Will be V only. So that V relative has become V. Thin layer having a mass delta M, that we are substituting it. Okay, these are the some basics is what happened. Today what happened, we have just covered it.